7, solving equations with one variable. We're going to look at the last learning target of the standard, learning target 3, and it's I can interpret solutions. So it's a lot like learning target 2, but we're going to actually solve equations, and then when we get to a point when we can interpret if that equation has no solution, infinite solution, or one solution. So we're going to start here with our first example, and as you look at it, it's almost like the last one, except for we're going to actually solve it, and I should say simplify it to the point where we can decide how many solutions there are. So the first thing I'm going to do is I'm just going to simplify this side over here, and I'm going to use that box method to look at the like terms. So when I look at the like terms, I notice I have a 35, which is a constant, a -8 as a constant, and a 4 as a constant. And if I take 35 plus a -8 plus 4, I notice that's 31. And the -7p is just hanging out because there's nothing to combine that is alike with -7p. On this side, I'm going to distribute. So I'm going to take -7 times the p, which is -7p. I'm going to take the -7 times -5, and that's when you take two negatives and you multiply them, you get a positive 35. And then I notice the -4 is tagging along. I reevaluate what I've got so far. I notice that I can combine some terms here since they're alike. So one more time, and I know I can combine the terms because when I box it up, if there's 3 boxes, I know I can at least simplify it down into 2 boxes. So I notice that the positive 35 and the -4. So if I add 35 plus a -4, that will get me 31. I'm going to drop down my -7p, and that was a positive 31. So notice that I'm going to put a plus sign there. I go back to my left side, and I'm going to look at what I have. So this is where that interpretation comes into play. And learning target 2, where we looked at coefficients. So I know the coefficient, which is the number in front of the variable, is -7. I look on the right side, it is also -7. So it has the same constants. And then I'm going to look at the constants of -31. I'm sorry, that's a positive 31, and this is a positive 31. So I notice that everything is the same constant, same coefficient. So I know I can stop right now and tell you that there's infinite solutions. I could put any value in for p that I wanted, and it would make this equation true. Next example. So again, we're just going to start by simplifying to see what we have so we can interpret. So I'm going to distribute first. So a negative times 3, or you can think of that as a -1, is a -3. A negative times the -6b, that is a positive 6b, and then the adding 10. Over on this side, I notice that there's no distributing, so I can combine like terms. I'm just going to put them in a box to make it seem so we can see the terms easier. 6b has nothing to go with, but +5 and a -3, both of those are constant, so I can add them together, and that would give me 2. I'm going to go over to this side. I notice there's still 3 terms. I'm going to look at it again, see if I can combine like terms. I can see a 6b, and I see a -7. I'm sorry, -3 and 10, and I know if I add those together, that would give me a positive 7. So, time to interpret. I'm going to notice my coefficients are the same. So if my coefficients are same, and then I'm going to look at my constants, and I have a positive 7 and a positive 2. So if my coefficients are the same, but my constants are different, that means I can interpret this as no solution. There is no way I can plug anything in for b when I multiply it times 6 on both sides, and then I add 7 to this side and add 2 to this side. It will never equal the same. And the last example. So I look at this left side. I already noticed that there's only 2 terms. There's 30 and a positive 6p. So there's nothing I can do. So I'm just going to write it down. I'm going to distribute the 7. So 7 times p is 7p. 7 times 6 is 42. And then I have subtracting 5. Since this has 3 terms, I'm going to look at it closely because there must be something I can combine together. I have a positive 42 and a negative 5. When I add those together, I get 37. So I have 7p plus 37, and then I have 30 plus 6p on the left side. Time to interpret different coefficients. This is 6, and this is a 7. So I can stop there because as soon as I see different coefficients, the only thing it can be is one solution. And the reason why, I'll kind of talk through this, the reason why I know there's one solution, because I could go ahead and then solve, I get rid of the 6p, and notice when I do that, I get p plus 37 equals 30. Then I subtract 37, and I get p equals a negative 7. You don't have to take it that far. You can stop right here as soon as you can interpret that you know that's one solution because it has coefficients that are different.